Hey everybody, this is Games Plus James, and welcome back to our Unity 3D platformer tutorial series. Now, last time around we made it so that our player can move around within the world, but the problem is right now, if we turn the camera, our player just twists and turns around with us, and no matter what direction we press, if we press sideways, our player still looks forward, and if we press backwards, we still go backwards and stuff like that. So we want to set it so that our player will not just point exactly where the camera is, but we can move the player based on whatever rotation we currently have and then start moving it in that direction. So let's start setting that up. First thing we need to do is set it so that, if I just play this again here for a second, we want to set it so that if we rotate the camera, the player doesn't rotate with us. And the way we want to fix that up is based on how we handle our rotation using the camera. So if I open our camera controller script, at the moment, when we try to rotate, what we're rotating is the target himself. So what we're going to do instead is rotate the pivot point. So we set it up the system that we have our pivot point to allow us to move our camera up and down as we're moving our mouse up and down. But now we also want to use that pivot point to rotate our camera left and right. So the way we're going to do that is, first thing we want to do is, instead of having our pivot go to be a child of the target, we no longer want our pivot to do that, because we want to have it so that our camera can stay facing one direction and then move our player in a completely different direction. So we want, for example, our player to move left and right. But if we have our pivot be a child of the player, then when the player goes to start moving left, it'll automatically rotate our pivot point and face us, have the camera facing the wrong way, which is completely not what we want to happen. So what we're going to do is just comment out this line of code like that, and what we're going to do instead is, in our update loop here, we're going to add a new line in to say pivot dot transform dot position equals target dot transform dot position. Okay, so that's fine. So what that means is now our pivot point will always move with the player. So let's just see if this is working okay for us. If we go and play the game here, we can see as our player moves, we move along with it perfectly fine, just the way we want it to. And that's all fine and dandy. That's exactly what we wanted to do right now. You can see our camera rotates, but our player is still rotating with us. So let's fix it so that our player no longer rotates when we move our camera. So how we'll do that is, here where we have our mouse X axis applying to our target, instead we're going to apply it to our pivot. So we're going to say, instead of target.rotate, we're going to say pivot.rotate. Like that. We can save that. And then down here, where we're moving the camera based on the rotation of the target and of the pivot and stuff like that, instead of moving it based on the target rotation, we're going to move it based on the pivot rotation. So pivot dot Euler angles dot y. Okay, so we'll save this, pop back into Unity, and once it's compiled and we can play. Oh, well, it's spinning around a little bit like crazy there. But you can see our player isn't moving as the camera is rotating, which is one step of what we want to achieve, but obviously we don't want it spinning around like a crazy maniac here. So we can fix that by, if we just stop this running here, on pause, we can fix it by making sure that our pivot point isn't a child of the camera. So basically what's happening is, we're making our pivot point move. When we move our mouse, our pivot point is supposed to move a little bit to compensate with that. But when it's a child of the camera, it's also moving the camera at the same time it moves the mouse. So the more we move the mouse away, the faster our camera spins around like crazy. Basically because our pivot point is still a child of the camera. So although we made it so that pivot point doesn't get set to be a child of the target object, we also want to make sure that we set our pivot dot transform dot parent equals null. Now we could of course do it so that our pivot point, for example, we could manually make it not a child of the camera, but the reason we want to leave it as a child of the camera is if in the future we want to say use this as a prefab, we can have this all perfectly set up for us. So all we have to do is when we want to use this camera, drop it into the level and put our target object of the player. We don't have to set up the whole pivot system again if we leave it as a child here. And we'll get into that as we go further into the series, but for now, just know that it's handy to leave this pivot as a child of the main camera. Okay, so now when we press play and we go to move our player, now you can see our player is there perfectly fine. We can move our camera around just like we wanted to before. And now our player doesn't turn with the camera, but at the same time, if we press forward now, our player will always go in the forward direction of the world. So no matter how much I turn this camera around, the player will always move in that one direction. So we're kind of back. We're back a little bit to a situation that we had before, but we know that we can change the player's direction based on where the camera is facing now. So let's stop this going here. And how we're going to change the way the player is facing is based in the player controller. So in the player controller, essentially what we're going to do is set it so that based on where the pivot point is currently facing, whenever we press any input down, we turn the player. If the player is, for example, if we want our player to face forward, and if we're playing the game and we press up, we want to turn our player so he's facing forward directly based on where the pivot point is facing. Or if we press down, we want the player to face the opposite way, or left or right, or anywhere in between along the way. So to do that, we'll obviously need a reference to that pivot point. So we'll say public transform pivot, we'll say. I think is the most straightforward way to do it. And we'll also need to know how fast we want our player to turn around within the world, basically. So we'll say public float rotate speed. Okay, so we want to do all this direction-based stuff kind of a little bit late down here. So we're going to do it after we've applied movement to our character. So what this will do, it'll kind of give us a bit more smooth movement within the world, basically. So what we'll do, we're going to type in, obviously, we'll put a little bit of a thing here to say, move the player in different directions based on camera look direction, we'll say. So what we'll do, well, like I said, we want to make our player rotate whenever we press any direction input. So we're going to do an if statement to check and see if, basically, as long as our horizontal input axis, our vertical input axis and our horizontal input axis, as long as either of them aren't 0, then we that means we're trying to move the player and we should do this rotation stuff. So here we can say if input.get axis, oh no, not get button, get axis horizontal is not equal to 0. So if our input on the horizontal axis isn't 0, or, so we say or by putting the two little vertical bars in like that. So if our horizontal axis isn't 0, or our input dot get axis vertical is not equal to 0. Well, if that's the case, then we're trying to move our player within the world, so we need to start rotating him. So how do we rotate him? Well, first thing we need to do is say, straight off the bat, we need to be facing wherever our pivot point currently is facing. So we can just say our current transform dot rotation. We want to set that to be a new quaternion. We don't need to say a new quaternion, but just quaternion dot Euler, because we're going to get the Euler angles. Oh no, that should be dot Euler. I just realized dot Euler. And on the x-axis, we want to leave that as 0 because we don't want to start our player rotating forwards or sideways or anything like that. So we want to say on the x-axis 0, but on the y-axis we want to set it to whatever the pivot dot rotation dot Euler angles dot y. So we want to get whatever rotation is making our camera rotate horizontally. So that is around our y-axis. So that's what makes our camera spin around. So we want to apply that same rotation to our player that's currently applied to the pivot. And then on the z-axis, we don't want to change that because that'll end up with our player either falling forwards or falling sideways. Okay, so we'll save this. Let's go back into the Unity and we'll see how this actually works for us. We need, of course, to hook up those little things we just set. So on our player controller, let's drag our pivot point into there. And our rotate speed, let's just set that to, we'll set it to 10 for now. It's not doing anything yet, but we'll just set a value on it. So now if we start our game, we can rotate our camera around, but now if I press up, our player will immediately turn to face that direction. Perfect. That's exactly what we want our player to do. So you can see now we can have our player, we can look the opposite way to the player, for example, and then press up and our player will start going that way. And also as long as we hold up and keep rotating the camera, our player will keep moving, just like that. So perfect, that's what we want to have starting off with. So now let's make our player face in different directions. We'll go back into our script. So the next thing we want to do, basically we want to work out what rotation angle we want to give to the player. And you notice there that we had a kind of, it very quickly snapped to the new position within the world. We don't want that kind of instant snap to happen. So what we're going to do is use something called a slurp to gradually rotate our player. It'll be a very quick rotation, but it'll be it won't be an instant kind of snap into position, which looks a little bit weird. And to do that, we need to create a new rotation object that will be our this is going to be our target that we want our player to rotate to be facing. So we'll say quaternion new rotation. So I can't spell rotation apparently. New rotation. So we're creating a quaternion object that we're calling new rotation, and we're going to set that to be equal to a quaternion dot look rotation. And a look rotation is basically, here is you give it a point in space within the Unity world, and then you say, okay, look towards this point. Make our player face this direction. So we can say here, in our look rotation, we have to give it a vector tree. So we're going to say a new vector tree that we'll call so what we want to do is say whatever our move direction on the x-axis is. So we know that that's what we're passing in for our inputs and stuff up here. Move direction dot x. We want to fill that in for our x-axis. On the y-axis, we want to put in 0 because we don't want our player moving up, or we don't want our look rotation to be going up or down in the world. And then on the z-axis, we also want to do move direction dot z, because we know that within our world, we're only moving on the x-axis. Let's just go back in here so we can just recap. We're only moving on the x-axis, our player like that, or the z-axis, side to side. Moving on the y-axis would bring us up in the air like that, and that would be no good because that's not how we want to be moving around. So this way here, what we're doing, we're saying that if our move direction on the x-axis, for example, should be say -1, then we're saying, okay, put a new target to -1 within the world. Well, not within the world, but a new kind of mathematical number of -1 within a mathematical theoretical space almost. So we're saying go to -1 on the x-axis and -1 on the z-axis, and that would be looking to the left and also back, so you'd be at like a 45-degree angle. It can be a little bit confusing, so let's just add the next little line and we'll see how it all kind of plays out into the game. So we want to apply this rotation to our player, and we'll do that by saying our Yeah, let's go for transform dot rotation. Oh, rotation equals quaternion dot slurp. So as I said, we're going to use a thing called a slurp, and a slurp is let me just do a quick little description of what a slurp is. So there's 3 kind of basic movement types within Unity. There's just move. Hold on. Let me undo this. I could actually type this, it would be a bit easier. We've got move towards. We've got lerp. And we've got slurp. And so these 3 different types are basically 3 different ways to move towards the same point. So if we have, say, a point here, let's use one of the brushes. We've got a point here and a point here, and we'll say the same for these 2 down here as well, just in case you haven't come across these terms before. So move towards basically happens, say these 2 objects are like 20, they're 20 between each one of these, right? And you have your move speed set to 5. So what'll happen is with move towards, say every frame you would have it move, if we just eliminate time, not delta time from this situation, you would have it move, it would move 5, so it would get to, say, here, then it move 5 again, get to here, 5 again, to here, and 5 again. So it would be equal speed moving all the way. But the way lerp works, lerp is like short for linear interpolation. The way lerp works is basically it says it takes like a percentage between these values. I can't remember the exact specific maths, but just for talk's sake, we'll just say it takes your 5 and it your 5 will increase the maximum amount of the spaces moves. But just for example, let's just say it'll move like 80% towards a value. So what'll happen is on the very first frame, it'll take your 5 and it'll multiply it by its move amount. So it'll go 5. Okay, I'm all the way to here. Then on the next frame, instead of jumping the same distance again, it'll go 80% of the way from here to here. So it'll go to, say, here, and that's what it's calling the 5. Then it'll go to, say, here, and then it'll go to here. So it's getting closer and closer, but it slows down all the time. And this is kind of the smooth movement that like a lot of animation will use in general. But the way slurp here works is slurp is specific for rotations. So instead of it going like in a straight line from like here to here to here, what it'll do instead is it'll go along an arc like this. So it'll still do the thing of like going to here and here and here like this, but it'll be a smooth kind of arc, and it's specifically used for rotations within Unity. So when you want to go from one point to another, you can't use a lerp when you're rotating objects, so you have to use a slurp. And that's kind of a brief overview of how that works. But anyway, so we've got a quaternion.slurp. So to use a slurp, what we have to do is say, where are we starting from? Well, we're starting from whatever our current transform.rotation is. We want to go towards our new rotation. So that's our new rotation. New rotation there. And then finally we have a third value, which is how long it should take to get there. And how long it'll take to get there is our rotate speed. So rotate speed. And we're going to multiply that by time.delta time to make sure that it's nice and smooth and it doesn't do anything too crazy. So we're going to save that, and we'll go back into Unity here. Let it compile. And now if I hit play, when we rotate, it's all fine. When I move forward, see our player goes into position there. And now if I move, oh, hold on, we're getting a bit of an error. Oh, I just realized what I did. So we've got our player within the world here. What I actually need to do is rotate the character model, not the player himself, because we only want to rotate like which direction this little object is facing, not the direction their actual input stuff is happening. So let's go back in here. We need a reference to that model. We need to say public game object, let's call it player model. And then down here, instead of setting the transform rotation, instead what we're going to set is the player model dot rotation. So player model dot rotation. That should be, sorry, player model dot transform dot rotation. Transform dot rotation. Okay, so we can save this. Go back in here. Oh, we've got a bit of an error. Where have we got an error here? Oh, we didn't put our semicolon at the end of that line. Let's go back again. Let that compile. Make sure we add our character model here into our player model slot. Now we press play, and now still, when we rotate the camera, our player will snap into the right position, just the way he should. But now if you press left, we see our player rotates to face the correct direction. So now we can run our player around within the world without moving our camera. And now as we move the camera, our player will move around with us. So there you go. That's how we can get like completely free movement of our player within the world. Nice and simple, nice and straightforward. But it ends up with suddenly our game feels a lot more alive. I will say at the moment it looks like our player is rotating very slowly. So let's up this speed to say 25. So let's try this again. There we go. That feels a bit better. Whee! Spinning around like a crazy dude. But there you go. We've got our player working nicely. We've essentially got all the basics of our player now in place. You'll notice when we start the game, actually, if I just stop and start it again, there's a brief second where our player kind of jumps in the air like that, which is obviously, that's not good. I want to double check on our animator. Yep, we do start off in the idle position. I think the problem is that the player, with the new skin settings we've set up on the character control and stuff like that, is just above the ground. So what I'm going to do is just move the player down ever so slightly. So let's see, this should fix it. Nope, of course it's not. We'll take a look at fixing that little bug either in the next episode or in a shortly upcoming episode, because it's not too much of a problem. But we've got all the basics of our character movement in place now in the game. There's nothing else we need to really make our character do for the time being. This is kind of the basics of what we want our character to do. So in the upcoming episodes now, we're going to take a look at how to make this more of a game by adding things like coins and extra lives and stuff like that, and dangers and how to kill the player. That's what we're going to focus on adding in the next few episodes. So thanks for watching, and I'll see you all very soon.